So I wanted to elaborate a little bit on something that I was talking about the other day. So grounds are really important. That's talked about. Most people know that. Um, a lot of guys say add a ground wire. I talked about before in kind of the overview um, that I don't run a ground wire on this. A lot of guys have. So I wanted to just show a couple things on the ground and what my method is. So before I show you how to use the meter, I'm going to show something here. This is copper anti-seize. And the reason that I use this is it's conductive. It's more conductive than aluminum anti-seize is. This stuff works real well. I put that in this connection in here. As I talked about before, this is the ground for the unit in here. And these are ARP studs, which are pretty common. I sanded off the material, the black oxide coating that's on here. And I put that copper anti-seize on there for a couple of reasons. It keeps it from corroding, and it's conductive. So that's on both sides of the washer and on the bottom side of the nut. And then the nut threads itself, I put some of that on there, and I ran it up and down a few times to kind of get some good contact going there. Now I'm going to show what I talked about before. There's no guesswork involved. If you've got an ohm meter and, use a good meter. Don't use a Harbor Freight $5.99 special. Those just don't work well, in my opinion. You don't need a fluke like this. This is a pretty good meter, but get something that's good, middle of the road. Spend 50 or $100 on a good meter. That's just in general when you're doing any kind of electrical troubleshooting, especially if you're going to trust your life to that, which I won't elaborate on that. What I'm going to be doing here is simply checking the resistance between this ground point right here and the battery, which is over here. And all I'm going to do is put my lead on the ground post over here and on the unit. And as you can see, I've got about 0.7 ohms, which is pretty good. These leads, and they're long, these are long leads I have on this. There's a little bit of resistance on the leads themselves. You can see I got less than an ohm of resistance. That's really good. Now, if I wanted to trace this back, in my case, this cable, my negative cable goes to the head. Of course, the head is attached to the intake manifold and to the unit. That's the path of the ground. I can actually move my lead from my battery to the head over here just to see what the resistance difference is. So as you can see, I've got it on the head here, and the meter is reading 0.6 ohms. So there's a tenth of an ohm difference between the battery through the cable into the head. I expect that there's going to be a little bit more resistance through the intake manifold, so I'm going to take and move my lead over to the intake manifold. We'll see what the resistance is there. That's the same. So I've got a good ground between my intake and my head. My guess is there's probably a little bit of resistance in the connection, and some of it is my leads. So I'm about a half an ohm, 0.6 of an ohm. If I check my leads, I've got 0.1. So there's still a little bit of resistance in between here. It's still okay, and I haven't had any problems with it. That's a lot of the reasons guys run a ground wire up here. Like I said, I found that I didn't need it. I could probably also tighten this up a little bit too. I haven't tightened this in a little while. Yeah, it was a little bit loose, and I bet I could probably get the resistance to go down a little bit. So if I put my leads on here, that's about the same, but that's good. You're not going to get much voltage drop with a half an ohm of resistance around that. That's just not a big deal. But I bet it doesn't take much to get resistance here. If I loosen up this connection here, it's probably going to make the resistance go way up. And it doesn't take a whole lot. So if I just loosen that up a little bit, you're going to see how much resistance there is going to be here. And there's, yeah, see, there's about 7.7 ohms. You know, we don't want that. That is going to give you voltage drop, because that's just like having a resistor in the circuit. You don't want that. So go ahead and tighten this back up. See if I can't tighten it while, yeah, see, there it goes. It's down to 1.9, 0.8, 0.7, right, 0.5. See, the tighter I get it, the better it gets. So that's about 0.5 ohms. That's very acceptable. You're not going to get very much voltage drop at all there. So that's how you check for a good ground on the unit.